We usually think of space as an empty, static backdrop where planets and stars simply exist. But Albert Einstein taught us that spacetime is actually a flexible, invisible fabric. When a massive object like a planet sits in this fabric, it creates a dip or a curve, which we experience as gravity. But what happens when that massive object starts to spin? It doesn't just sit in the fabric, it actively grabs onto it. This brings us to a mind-bending phenomenon called frame dragging, or the Lense-Thirring effect. Because spacetime is woven together with the mass inside it, a rotating object literally twists and drags the fabric of reality around with it as it turns. Think of spacetime not as an empty vacuum, but like a thick jar of honey. If you place a spoon in the center of the honey and start spinning it, the fluid closest to the spoon will swirl and be dragged along with the rotation. Planets and stars do the exact same thing to the space around them. This isn't just a wild mathematical theory, it is a scientifically proven reality happening right now. To prove it, scientists launched the Gravity Probe B satellite, equipped with the most perfectly spherical, ultra-precise gyroscopes ever created. As the satellite orbited our rotating planet, scientists measured a microscopic but undeniable twist in the gyroscope's orientation. Earth was physically pulling the local spacetime fabric around with it, forcing the gyroscopes to drift out of alignment by a tiny fraction of a degree. While Earth's frame dragging is incredibly weak, things get terrifyingly extreme when we look at the universe's heavyweights, rotating black holes. Around a spinning black hole, spacetime is dragged so violently that it creates a chaotic swirling region called the Ergosphere. If you were to fly a spaceship into this region, the fabric of space itself is whipping around the black hole at impossible speeds. No matter how powerful your engines are, you would be forced to physically rotate along with it. You couldn't stand still even if you tried, because the very concept of stillness ceases to exist in that space. Ultimately, frame dragging forces us to completely rethink our universe. It proves that we aren't just moving through an empty void, the planets, stars, and black holes are actively churning, twisting, and stirring the fundamental geometry of the cosmos around them.